Hello and welcome. So, given the complex number below, find the following. Alright, it asks us to find or determine which quadrant we're in for the complex number, the modulus of the complex number, and then finding the argument of it. Okay, now this first blank and the argument are tightly linked. The modulus is kind of the only thing that's kind of on its own there. So first off, in order to kind of work with this, to find the quadrant, craft the complex number, right? So I'd say, okay, it's a comma b, so a plus bi, right? It's the real comma imaginary. So we have 6, so we're going right 6. I'll put 6 about there, right? And then we're going down 12, right? So your complex number will be there where we're going a to the right and b down. Okay, so that means that our complex number is in quadrant 4. Remember, quadrants move counterclockwise, so quadrant 1, 2, 3, and 4. Okay. Alright, so now it says find the modulus. The modulus refers to the distance from the origin to that complex number. Right? Say, okay, well, I know that the distance to the right is 6. The distance down is 12, and my hypotenuse of that newly formed triangle, winkety wink winks, is the modulus of the complex number, right? So if we use a squared plus b squared equals c squared, Pythagorean theorem, a, b the legs, c is the hypotenuse, right? If you wanted to solve for the hypotenuse, you would just take the square root of whatever the sum of the legs would be, right, after you square them. So that means that the modulus of our complex number is essentially going to be our legs of the triangle squared under a square root. So I'd say, okay, well, 6 squared plus negative 12 squared square root. There is your modulus of w. Simplify, right? So 6 squared is 36. 12 squared, 144. Square root. So then add those two together, 36 and 144, let's see, what is it, 180, I think? Square rooted. Okay, now that technically is the modulus. If it simplifies, we got to simplify it, right? I'm just going to do 10 and 18. Alright, this is going to be 3 and 6, which is 3 and 2. 10 is 2 and 5. Do we have two of the same thing? You bet we do. We got two 2's. We have two 3's, and there's a single 5 left behind. 2 times 3 is 6, and then 5's left. So 6 root 5. If it simplifies, simplify it, right? Answer is a simplified exact number, okay? All right, the argument. This is where it gets a little more interesting. The argument is from where the rotation starts, which will always be that positive right side of your coordinate plane there, right? And it'll go to that hypotenuse of the triangle, to the modulus. You'd say, okay, well, that's nice. How do I find that? Well, would you agree that if we know the angle inside of that triangle, we could find the hot pink, that remaining portion? Okay, so if we find the negative angle down, okay, we'll know where we need to go. So all we have to do from there is just use inverse tangent. So I'd say, okay, the reason why we're using tangent is using the opposite and the adjacent sides. Okay, opposite and adjacent. So I'd say, okay, so tangent of the angle in that corner equals the opposite over adjacent. Okay, if you wanted to solve for theta, you undo tangent with its inverse. Okay, undo tangent with its inverse. Theta equals the inverse tangent of negative 12 over 6, which I'm just going to simplify to negative 2. And there you go. There is the angle inside of that triangle. So I'd say inverse tangent of negative 2. And we get negative 63 degrees. I'm going to round to the nearest whole. Negative 63 degrees equals negative 63. That means that we have an angle of negative 63 in here to go from the coordinate or right side of the coordinate plane down to the hypotenuse of that triangle. Well, I know that all the way around here, that's 360. So if you add 360 to that negative 63, that'll leave you that hot pink portion, the argument that we're looking for. So add 63, oops, 63. Add 360. I was like, wait a minute. Negative 63 plus 360, and you're at positive 297. Alright, so 297 degrees is your argument. And you're like, okay, that's nice, Miss Diddy. What if I'm not in quadrant 4? What do I do? Let me just give you the general key. Alright, if you're curious as to why, check out the tutorial problem video. I explain it in a lot more detail there. Right? But quadrant 1, essentially, you're not adding anything, right? Leave it the way it is, add 0. If your complex number is in quadrant 2, add 180 to it. If it's in quadrant 3, again, add 180 to whatever you get for that inverse tangent. In quadrant 4, add 360. Right? And if you draw out the complex number, you can see why we add each one of these that we do, but that's going to be helping you out to find each quadrant that you need to find. Right? But that's essentially the process you go over. Thanks for watching!